Good day everyone, I am Babes A. Canson and I'm going to show you my report about vectors. But this presentation is just a continuation of Miss Kabakab report. So what we ended with Miss Avi's report is we talk about unit vectors. We talk about if you take a vector and you divide by the magnitude, you're gonna get a unit vector, and that process is called normalizing. So we're gonna do another example real quick before I talk about another form of vectors. Here's the given problem. We're going to find the unit vector in the direction. We're gonna call our vector A that is gonna be 2i subtract j subtract 2k. So I want a vector that is in the same direction, but that has a magnitude of 1 that will make it a unit vector. So how are we gonna start to find the magnitude? So yeah, this is what we should do. You're gonna take the square root of each coefficient. So we have square root of 4 plus 1 plus 4. And we end up with a magnitude of 3. So now, what you're gonna do is you're going to divide your vector by 3 so that we have a length of 1. So I'm gonna call this that is a unit vector. That is one way you can write it, other ways is a bracket notation. So that would be our unit vectors that is in the same direction. So now, oftentimes we want to write a vector in terms of direction, which is gonna be a unit vector and a length. So that's what we're gonna talk about next, is when we have vectors that are determined by length and angle. Here's that form that I can write vector as the product of its length and the angle that it makes with the x-axis. That will be the vector cosine theta, comma, sine theta. This is obviously the length. This part we call direction of the vector. So oftentimes we'll be asked to write a vector in terms of its magnitude and its direction. Okay, we have here an example. We're going to find the angle that vector v is gonna be the vector negative root 3 comma 1. We're gonna find the angle that the vector makes with the positive x-axis. Okay, we're gonna take the vector v so that the negative root 3 comma 1, and we want to write that as the product of its magnitude multiplied by its direction. So theta ultimately is what we're looking for. If you find the magnitude, you're gonna find that it's 2. So once we divide by 2, we're gonna get our direction vector. This tells us two pieces of information. It tells us that cosine theta is negative square root 3 over 2, and sine theta is 1/2. Therefore, what is theta? So I have here theta is 5 pi over 6. I hope you understand the form of vector using length and angle. So okay, last thing we need to talk about is applications. So today we're going to be talking about forces. So forces are often represented by vectors because they have length and direction. So if two forces are applied to the same point, they are called concurrent. Concurrent is the term that you heard in physics or anything. So concurrent forces applied to the same point, well, we are interested in the resultant force. So next is that two forces together form the resultant force is going to be the sum of two forces applied to the same point. So we are going to do one example. Okay, suppose two forces are applied to an I bracket. Find the magnitude of the resultant and that it makes with the positive x-axis. And then this is the resulting figure. Yes, we have 30 and 40 degrees. So first thing we need is we need two forces in a more helpful form, like maybe a bracket notation. So that F1, the first force, we know that the magnitude is 200 and we know that we have an angle of 30, so we can write it in terms of its magnitude and its direction. So this will be 200 cosine of 30 comma sine of 30, so that the first force then cosine of 30 square root of 3 over 2. So this will be 100 root 3 comma 100. So the second force, we're gonna write in the same manner. Magnitude is 300 this time. We have cosine of 70. So please do not run out until the very end. We're just gonna leave this as 300 cosine of 70 comma 300 sine of 70. So then our resultant force is gonna happen when we add our two forces together. So right now we're gonna add these two together to get the resultant. So this will be 100 root 303 plus 300 cosine 70 comma 100 plus 300 sine 70. Then this is about 275.8 comma 381.9. Okay, now we have the resultant force. We are asked for the magnitude and the angle it makes with the positive x-axis. Okay, the magnitude of the resultant ends up being about 471. So what we can do then is we know that the cosine of theta, there's gonna be this number divided by the magnitude. We could choose cosine. So we have here the data and end up being 54.2 degrees. And that's the end of my discussion. I hope you learned something. Again, I am Babes Ikanson. Thank you for listening.